Formation of what? Protonated alcohol means we are going to add one more H+. Formation of carbocation is the rate determining step as it is the slowest step. Methanol is poisonous. It is poisonous, and if it is ingested can cause blindness or even death. Alcohols are heated with protic acids. Now what are protic acids? Which are able to release H+ ions. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with session 4 of the chapter Alcohols, Phenols and Ethers. So in the last session we discussed the physical properties of alcohols and we started with the chemical properties of alcohols, right? So it was classified into two main parts. The first one was reactions involving oxygen-hydrogen bond cleavage, right? So that is what we have discussed in the last session. So in today's session we are going to study the reactions involving cleavage of carbon-oxygen bond, right? And then dehydration of alcohols, identification of primary, secondary and tertiary alcohols, as well as properties of methanol and ethanol we are going to discuss in this session, right? Okay, so the first one, reactions involving cleavage of carbon-oxygen bond in alcohol. So oxygen, so already the cleavage of oxygen-hydrogen bond was discussed in the last session. So the first one is dehydration of alcohol. So this is a reaction in which there is a cleavage of carbon-oxygen bond. So what does dehydration of alcohol means? What does dehydration means? D means we are going to remove something. Hydration means we are going to remove water, right? Dehydration means removal of water. So alcohols are heated with protic acids. Now what are protic acids? Which are able to release H+ ions, right? Protic acids such as concentrated sulfuric acid or concentrated phosphoric acid at 443 Kelvin, dehydration takes place to form alkenes. So alcohols undergo dehydration to form what? Alkenes. So this will happen in presence of concentrated sulfuric acid. So it is a very good dehydrating agent, right? Okay. So as you can see, this is an alcohol which is shown here. So I'll just mention hydrogen here. So this is methanol, right? CH3 OH you are having, and what happens here? Hydrogen and hydroxyl group will be removed. That is, one hydrogen and one OH will be removed, and in place you will get an alkene. So for example, let us take CH3 CH2 OH, which is ethanol. Ethanol undergoes dehydration in presence of concentrated sulfuric acid at 443 Kelvin. What happens? One hydrogen from here and OH will be removed. So what happens? A double bond will be formed here. It will be CH2 double bond CH2. So this will form an alkene, which is ethene. I hope it is clear, right? So this is an example. Ethanol undergoes dehydration by heating it with concentrated sulfuric acid at 443 Kelvin. So what you are going to obtain? You are going to obtain ethene, and what is being removed from here? Water is being removed. Hydrogen from here and OH from here is removed. So there will come a double bond between the carbon atoms. So what bond is broken here? Carbon-oxygen bond is broken here. Not oxygen-hydrogen bond, right? Carbon-oxygen bond. This bond is being broken. Now, the secondary and tertiary alcohols are dehydrated under milder conditions. So this was a primary alcohol that we discussed. Now in the case of secondary and tertiary, alcohols can also be dehydrated but under milder conditions. Primary requires some more higher conditions, right? 443 Kelvin and concentrated sulfuric acid, which is a very good dehydrating agent, is required. So in this case, this is a secondary alcohol, right? So 85% of phosphoric acid is required at 440 Kelvin. What happens again? OH and hydrogen is being removed. So you get a double bond here, right? Double bond here, and water is being removed. So this is a tertiary alcohol. So what you can see again, hydrogen and oxygen will be removed. So you get a double bond here. 2-methyl propene is obtained. Thus the dehydration of different types of alcohol is in the order. Tertiary alcohols will undergo dehydration faster than secondary alcohols, than primary alcohols. So this order also you can remember. Dehydration, tertiary goes first, then secondary, then primary. Right? I hope it is clear. Now, the mechanism of dehydration of alcohols, which is important. So wherever I am discussing mechanism of various reactions, it was very, very important. That is important for your examination point of view as well. Okay. So as discussed now, we know that hydrogen and hydroxyl group. H and OH will be removed and you will get a double bond there. But how exactly this is happening is what we are going to see now. So ethanol is taken here, CH3, CH2OH. And first step is formation of protonated alcohol. Formation of what? Protonated alcohol means we are going to add one more H plus. Okay, so alcohol undergoes protonation, gives protonated alcohol. So we are going to add H plus to it. What is going to happen? This oxygen will donate its electron to this hydrogen, that is a H plus ion, your proton, and what happens? You get that hydrogen here. And as it is accepting this H plus, what will happen to the oxygen? It is giving its electrons to the hydrogen, right? So the oxygen will get a positive charge. So this is called as protonated alcohol because it is having a positive charge. So this is the first step where the oxygen is going to get a positive charge. That is why it is a protonated alcohol. Next step is formation of carbocation. So this is your protonated alcohol. Now what is going to happen is you are going to get a carbocation. Protonated alcohol loses water molecule to form the carbocation. It is the slowest step and hence the rate determining step of the reaction. So it is important to remember this as well. The step 2, that is the formation of carbocation, is the rate determining step as it is the slowest step. So as you can see here, protonated alcohol which is formed in the first step. Now what happens? As you can see, HOH. Now what is this? It is water, right? So this much will be broken, that is this carbon oxygen bond will be broken and water will be removed. Now when this water is removed, what will happen to this positive charge? As you can see here, this electron is being shared between the carbon and oxygen. Oxygen is taking up the electrons and moving so that it is removed as water. So what will happen to the carbon? Carbon's electron is being lodged, so it gets a positive charge, right? So you get a positive charge which is the carbocation and water will be removed. So this much part will be removed. So what is left behind? CH3, CH2 and plus because carbon has lost its electron. So that is the formation of carbocation which is the rate determining step. Now the last step is elimination of proton. Elimination of proton from carbocation forms an alkene. So this is your carbocation which is formed. So now what is going to happen? We are going to remove the proton from here. One H plus will be removed. So what you are going to get? CH double bond CH, right? You will have these two CH and these two CH. So CH double bond CH and H plus will be removed. So this is how you are getting an alkene from an alcohol. So this mechanism is also important, right? Now, the next one is identification of primary, secondary and tertiary alcohol. So, if you are given an alcohol, how can you identify whether it is a primary alcohol, secondary alcohol or tertiary alcohol? So, there is a test which you can do. Based on the result that you are going to get, you can identify whether it is a primary alcohol, secondary alcohol or tertiary alcohol. So, this is very important. The name of this test is Lucas test and the reagent that we are going to use is Lucas reagent. Okay. So, a solution of anhydrous zinc chloride in concentrated hydrochloric acid is called Lucas reagent. So what is Lucas reagent is also necessary to study. What is Lucas reagent? It's a mixture of zinc chloride, anhydrous zinc chloride and concentrated HCl. Okay. So it is a mixture of anhydrous zinc chloride and concentrated HCl. So this is your Lucas reagent which will help you to identify primary, secondary and tertiary alcohol. So to alcohol, if you are going to add Lucas reagent, primary will give you a different set of reaction, secondary will give you a different observation and third will give you a different observation. So let's see. Lucas reagent is a convenient reagent to differentiate between primary, secondary and tertiary alcohol. Tertiary alcohols reacts very rapidly to give an insoluble layer of alkyl chloride at room temperature. So this tertiary alcohol, to tertiary alcohol if we are adding Lucas reagent, it will react immediately and it shows what? Turbidity will be shown. Immediate turbidity. That means it won't be completely soluble. An insoluble layer will be there. Immediate turbidity will be there. Now secondary alcohols reacts in several minutes. It will take around 5 minutes for the turbidity to appear. Whereas primary alcohols form alkyl chlorides only on heating. Okay. So tertiary What will happen to tertiary? Immediately it will show turbidity. Secondary it will show after 5-10 minutes. And primary, it does not show turbidity directly, but if you heat it, it might show the turbidity. Zinc chloride probably assists in the breaking of the carbon-oxygen bond of the alcohol. The time taken for the appearance of turbidity is different in these three types of alcohols, can be used to distinguish primary, secondary and tertiary alcohol. So based on the time which is taken to show the turbidity, we can say whether it is primary, secondary or tertiary. If it shows immediately, it is tertiary. If it shows after 5 minutes, it's secondary. And if it shows only on heating, it is primary. So this test, and what is Lucas reagent? It is also very, very important. So Lucas reagent, that is anhydrous zinc chloride and concentrated HCl. If it is a tertiary alcohol, what will be formed? A tertiary halide will be formed, right? Tertiary halide means what? Instead of OH, what you are going to get? It will be chloride which is substituted. For example, if I am taking methanol and adding zinc chloride and concentrated HCl, what you are going to get is CH3Cl. Okay, zinc chloride and HCl if I am using, instead of OHCl will be substituted. So that is what is being formed. Okay, tertiary halide, immediate turbidity. Secondary alcohol, if it is turbidity after 5 minutes. And if it is primary, turbidity only on heating. Right. Now, the next one is by dehydrogenation. Okay, dehydrogenation. Now, what is dehydrogenation? We are going to remove hydrogen, right? D stands for removal, hydrogenation. We are going to remove hydrogen, right? When the vapors of alcohol are passed over heated copper or silver catalyst at 573 Kelvin. If it is a primary alcohol, if we are using, primary alcohol undergoes dehydrogenation to form aldehyde. So, primary alcohol undergoes dehydrogenation to form aldehyde, right? So RCH2OH, so this R can be anything, CH3, C2H5, any alkyl group. So in presence of copper or silver at 573 Kelvin, what is going to happen? As discussed, hydrogen is going to be removed. One hydrogen from here, one hydrogen from here. So what you will get? RCH, and this will be double bond, okay? RCHO and hydrogen will be removed. So you will get an aldehyde. So I'll just write it down here, CH3, CH, and one H I am going to write like this, and OH. Okay, so now what happens here? This H and this H will be removed. So what is left behind here? CH3, CHO. So what will happen to this bond? This bond will become a double bond. Okay, now CH3, CH2, OH in presence of copper or silver at 573 Kelvin. Again, what will happen? One hydrogen and one hydrogen will be removed. So what will happen? CH3 and what is there? CHO. CH3 and you have CH. Only one hydrogen is removed from here, right? And you'll get a double bond. So that will be acetaldehyde, which is formed by the removal of hydrogen. Now, that is regarding primary alcohols. So, when primary alcohols is undergoing dehydrogenation in presence of copper or silver at 573 Kelvin, you will get what? Aldehydes. Now, secondary alcohols undergoes dehydrogenation to form what? Ketones. So, the same thing we have studied in terms of oxidation as well, right? Oxidation also, what was happening? Removal of hydrogen, right? Now, this is a secondary alcohol taken. Now what will happen? Again, hydrogen and hydrogen will be removed. RC double bond O R dash you are going to get. That is ketone, and hydrogen gas will be liberated. Now CH3, CHOH, CH3. Isopropyl alcohol, again hydrogen will be removed. CH3CO, CH3, acetone will be formed by the removal of hydrogen. Okay. Now, what about tertiary alcohols? It undergoes dehydration to form corresponding alkene. Okay. It will form what? Alkene. So, what you have to remember here is primary will undergo dehydrogenation. Secondary alcohol will also undergo dehydrogenation. But tertiary alcohol will not undergo dehydrogenation. It will undergo dehydration. Water will be removed, not hydrogen. So, CH3, CCH3OH, that is tertiary alcohol. It is tertiary butyl alcohol. Again, the same condition, copper or silver at 573 Kelvin. Instead of dehydrogenation, what is going to happen? Dehydration. Dehydration is going to happen. That is, we are going to remove water from here. That is, one hydrogen will be removed from here, one OH will be removed from here. So what will happen? A double bond will come between these two, which is represented here. CH3C, CH3, double bond CH2. So in between this carbon and this carbon, a double bond will be formed. So what you have to remember, tertiary alcohols do not undergo dehydrogenation due to absence of tertiary hydrogen. Okay. So what you have to remember, primary alcohol will undergo dehydrogenation to form aldehyde. Secondary will undergo dehydrogenation to form ketone, and tertiary will not undergo dehydrogenation. It will undergo dehydration and form alkene. Okay. So I hope the reactions are clear for you. Now we are going to specifically study some important points about methanol and ethanol. So properties of methanol we are going to study. What is methanol? CH3OH, right? One carbon containing alcohol. The simplest alcohol is methanol. So methanol is a colorless liquid. The boiling point of methanol is 337 Kelvin. Methanol is poisonous. It is poisonous, and if it is ingested can cause blindness or even death. So it can't be directly consumed. It is very, very poisonous. So methanol is mixed with ethanol. It is mixed with ethanol and sold in the market as spirit. It's mixed with ethanol. Methanol is used as a major solvent for paints and varnishes. It is also used as antifreeze for automobile radiator. It's used for denaturing ethyl alcohol. Ethyl alcohols means what it is? Ethanol itself, denaturing. Now, methanol is used for the making of formaldehyde as well. So, we already know alcohols, if it undergoes oxidation, what you can get? You can get an aldehyde. So, it is used for the preparation of formaldehyde as well. Now, the next one is ethanol. Ethanol is used as a solvent in paint industry. In power alcohol, okay, what is power alcohol? Power alcohol means 80% petrol and 20% ethyl alcohol. Ethyl alcohol means ethanol itself plus traces of benzene. Power alcohol is used as a motor fuel, right? And in alcoholic beverages also, it is not methanol, it is ethanol which is present in the beverages, okay? So, I hope this is clear. So, by this, we come to an end to this discussion of alcohols, right? So, the same, we are going to proceed with phenols. We are going to study the classification of phenols as the nomenclature of phenols in the next session. So, I hope the concepts that I have covered in this session is clear for you. So, that's all for today. Thank you.